Hello everyone, welcome back to a new video. In this video, we are going to talk about how we can create a self-managed cluster, self-managed Kubernetes cluster in GCP, Google Cloud Platform. So for that, I have created a short tutorial, which I will link on the description as well. And we are also going to use the official documentation of Calico, which is Tigera. So if I show you my VM instances, then I have already created a self-managed cluster here with one control plane and two worker nodes. And I'll do the same again. So this time also we will have one control plane and two worker nodes. But the idea is similar. If you want more worker nodes, you can customize it accordingly. Let me close this window and let me go here. So you have to go to your console.cloud.google.com, and if you are a new user, then register and sign up and do all those things. You'll get some credits to get started. So you can go to the navigation menu, go to the PVC network and go to the PVC network option. And you can see that we have two VPC networks right now. So this one is the default one. It is already present here. And then I have created the K8 VPC. So we will create another one. Before that, VPC is virtual private cloud. So why are we creating it? So that our cluster that is inside the VPC network will be safe and it will have secure communication between its components, and only limited traffic will be allowed basically, which will be configured through firewalls. So VPC is nothing but a private network where we will have our cluster. Let's call it VPC network 2. And then let these things be same as the default values. Then we are here at the subnets. So we will create a subnet. The previous subnet was called K8 subnet. I'll just call it K8 subnet 2. And then the IP stack should be the same, IPv4. I think we should first look at this documentation. This will help us. So this is just basic introduction. In this tutorial, these guys are using gcloud, which is like CLI that we use with GCP. So we will actually do everything here, not on the CLI, but these will be helpful anyways. So firstly, we can see that it has created a subnet called K8 nodes, and then the range is this. So we'll simply copy it, and that is what IPv4 range will be for us. And I think it is good to go. And the next thing they'll do is create a firewall rule. So that is the next step that we will also do. For now, let's move ahead. We can say done. Subnet has been created. But it says that we also have to give the region. So I forgot to mention the region. I think it should be Asia South 2 for me because I am from India. And you can choose a respective region which is closest to you. Now let's do done. And firewall rules, we are not going to set any firewall rules right now. We can simply go and create the VPC network as well as the subnet. So it may take some time. You can also have a look at the notification section here. So as soon as the VPC will be created, you will also be notified here. After waiting for a few minutes, the VPC network 2 is ready. So, but right now you can see we do not have any firewall rules. So the next thing that we will do is set up those firewall rules. Go inside the VPC network 2. And now what we will do is, firstly we can see our subnets here. So we have our subnet here. Then what we will do is we will create a firewall. So firewall is used for allowing or blocking all the traffic that's coming from different resources. So by the help of firewall, we will be able to, like, the cluster that we are going to create, we will be able to make sure that no unauthorized access or no unauthorized traffic comes to that cluster. We will go and we will say add firewall rule. So let's call this one internal. We have this internal rules cage. I'll call it internal rule cage and I'll call it 2 because I already have one firewall which is named internal rules cage. Then there is network. So we have to be in the VPC network too, which is correct. Targets, we will say the target will be all the instances in the network. So maybe we will be opening additional ports here, but I think that is fine. Then we come at the IPv4 ranges. So here we will set the range or the IPv4 range that we set initially for the VPC network, which was this. And now we will go to the ports and protocols. Here we can select TCP and we can select UDP. And now we will write the ports. So how are we going to know which ports do we need to open? For that, we'll simply go to the Kubernetes documentation. In the Kubernetes documentation, we would simply search for, let me search for ports and protocols. So yes, go to the first link. And here we can see all the ports that are required for the control plane as well as for the worker nodes. So that's what we will do. For this one, we need the ports on the worker node. So that's what we will do. And additionally, we need some more ports. In this case, if you see, they have allowed all the traffic from these protocols. So you can either copy that, or I would rather add all these. So if we look at the ports, this is 3000. So this is the one, and then there is 10 to 50, 10 to 56. So we have the 10 to 50 and then we have the 10 to 56. Only the one additional port that we have opened is 179 port, and this will be for the Calico networking basically. Then we will also open one UDP port, which will be 4789. And I think this should be good. So we can go and we can create this firewall rule. So the first firewall rule was created. We'll do the same again. We'll create another firewall rule. Let's name it. Let me call it external cage rule. Let's add 2. Then network remains the same. And direction of traffic, ingress, action on match allow. So you can keep them as default. And then for targets, I'll say all instances in the network again. Then in the IPv4 ranges, we can simply say the 0.0.0/01. And coming to the ports and protocols, we'll open the TCP protocol. And for that, we will add all these ports. So you can add them manually, but I already have them in the history. So let us match them. First one is 6443. So we have 6443. Then there is 10 to 50, 10 to 57, 10 to 59. So we have 10 to 50, 10 to 57, 10 to 59. And then there is a range which starts from 2379, 2380. This is 2379, 2380. This is perfectly correct. One more port that we should open for SSH is 22. I think this is already open, but just to be safe, I'm adding this. But otherwise, as far as I remember, one port for SSH is already opened in the VPC. I think this should work fine now, and we can create the second firewall rule. So we have two firewall rules open here, and if you open these up, there's not much detail, but I think it's good. Now since we have created a VPC network, we have added the subnet, we have also added the firewalls for communication. What we can do now is we can simply go to the compute engine part, and there you'll find VM instances. So click at VM instances and you will reach here. Now what we are going to do is we are going to create the VM instances for different nodes. So go to the create instance. So now let's name our instance. Let's call it control plane. I'll call it C control plane. So it's fine now. Let's choose a region. So I will choose Asia South 2, which is Delhi, which is the closest region to me. And then the same thing here again. Okay, we can keep it any. Then for the machine that we want, you can keep it E2 medium, but just for safety, I'll go to standard and I'll choose the E2 standard 2 machine, which basically comes with 2 CPUs and 8 GB of memory. Then is there anything else? Yes. So just don't click create right now. There are a lot more things we have to configure. Go to the OS part. We should change our OS. Let's go to Ubuntu. We can keep this at default. If you want more size, you can increase the size here, but I think this will be enough. I'm choosing 10 gigabytes as size, and then we can do select. Then for firewall, keep it as default. Network tags, we are not going to add any. Hostname also, we will just leave. And then for network interfaces, we will choose the network, which was VPC network 2. And then for subnet, we'll use this one, K8 subnet 2. And network interface card, I think we can keep it as default. Let me check. Yes, we can keep it as default. And then the primary internal IPv4 address, we can keep it as default. Then I don't think we have to add anything else. So we'll click on done here. Then let's go to observability. I don't think we have to add anything. For security also, but we would need SSH, right? So we will have, okay, so SSH is here. Add manually generated SSH keys. So we'll click add here. Now how I create SSH keys is I use something called putty generate. So if you do not have this you can install it, putty generate key generator. Here what you have to do is, after installing it, it is quite simple to install, so you can do that very easily. Why am I doing this? Because for Windows, putty is the best way to run, basically to SSH into your virtual machines and then use those. So through putty generator we can SSH into, for example, control plane, and then we can perform all the tasks that we want to perform in the control plane. If you are into Mac, then it is much more simpler for you. But for Windows, what we will do is we'll simply download the putty key generator, and then you just have to click here at generate, and then you have to randomly move your mouse over the blank area, and it will create a randomized code for you out of this. And you can see we have this randomized code. We can simply copy it here. We can simply copy it and paste it here. And then when you go to the putty, not putty generate again, when you go to putty, then you can write the IP address here. So here you can add your SSH key and then click on add key. You can generate, you can basically then, like for example, after you have created this, you can go to your master node from here. You can simply say open and it will take you to the master node. Currently it will not take me anywhere because, or maybe it will take me to the master node which I created previously. Let me try open. And it is taking some time. So it does not take me to the master node because the SSH key that I have added there was of a previous uh, virtual machine instance that I created, which is now been deleted. That's why it did not take me there. For this tutorial, I just wanted to show you what putty is and how putty works. So this has been added, and let's check out advanced. I don't think we'll have to add anything here. So everything looks good, and we can simply go and click on create. So after taking some time, the C control plane VM instance is ready. And if you want to do SSH into the C control plane, you can simply do it from here if you don't want to use putty. And now what we will do is we'll go to the C control plane, and we will simply select the create similar option. So it will help us create a similar virtual machine. Now the name of this one should be, this time I'll call it node 01, and all this is correct. This is also fine. Also, one thing I forgot to mention in the C control plane VM instance was the monthly estimation here. So you can also have a look at how much the monthly cost has been, because this is very important. And if you choose the machine which is of lower, which basically has lower CPU and lower memory, then the estimate will be lesser. And if you choose the correct region, then the estimate will be lesser. Make sure to also factor in your budget and what you are going to use. For me, I have a few credits, that's why I can select this one. OS is also fine. Networking, this will all remain the same, and we will go to the VPC network too. So I don't think I need to make any changes here. So the primary internal IPv4 address is mferal, which is fine. External is also the same. So I think this is done. So we can click on done here. So in the observability, I don't think we needed to change anything. Same goes for security. We did have to change a few things in security, like adding the SSH key, but this is the same SSH key from the previous C control plane, so it will work fine. And this will also be fine, I think. So we can go and we can click create. We can do the same thing again. We can go to C control plane, create similar. Let's call it node 02. Everything else is fine. This should also be correct. And then in the network interfaces, we need to change nothing here. Observability, security, nothing has to be changed. Advanced, nothing has to be changed. And we can also create. So it will take some time and the node 02 will also be up. We did not look at this again, but we created in this case, we created two firewalls. Here also two firewalls are being created. One for the external uh, communication and one for the internal communication. So you can have a look at these things. These are exactly the same thing that we did, but through CLI commands. And then they have created 3 worker nodes, which is quite similar. They are installing Docker, but I don't think we will install Docker. We will use containerd as our runtime, and then they go there and download all other things. So which is pending for us to do. Now what we can do, this is the one we created recently, C control plane. So I will SSH into the C control plane. So after some time, we could do SSH into the C control plane. Let me clear everything. And now what we have to do is we have to follow the tutorial, the notes that I have made. Now what we are going to do is we are going to run all these commands. So the first command is to disable the swap. So for that, you can simply copy this and paste it here. Then the next step is to configure the IPv4 forwarding and the IP table for the bridged traffic. So we can simply again copy this command, paste it here, and then just press enter. And the next step is to set up the sysctl parameters. Simply copy this again and you will paste it here. I can clear this screen. After this, we can verify the modules in the parameters by running this command. And if everything works fine, now we can move on to installing the container runtime, which will be containerd. So we are not going to install Docker like the people here installed it. We will rather install the containerd. So I'll simply copy the command, paste it here. It will take some time to install, to download the binary from its GitHub release, and then we'll simply do enter. Let me clear the screen again. Next, it says that now we will set up the default containerd configuration, and we can simply run the command. Again, clear the screen. Now we are going to start the containerd service, which we do using systemctl. So whenever we have to start or restart all these services, then we do it through systemctl. So firstly, what we do is we will do a daemon reload. Let us do that. And then we will enable the container D. And now it will show us the status of container D, which should be running if everything works fine. So it does say active and running. So this basically means that the container D has been set up and it works fine. You can exit it and then clear the screen. Now we will install runc, which is another lightweight container runtime. And the container D under the hood uses runc. That's why we are installing it. And we will simply run this command. Now that this is installed, now it is time for the CNI, container networking interface. So we'll simply install the CNI plugin, press enter. Let me clear the screen again. And now what we are going to do is we will install kubeadm, and then through the help of kubeadm, we'll be able to install all the control plane components. It is also possible to install all these control plane components binary and do that manually, but it will take a lot of time. That's why we are going to use kubeadm. So let me do sudo apt-get update. So after some time, it will be updated, and then we will run this command. And it has been successful. Let's go and run this command now. So it gives me an error. There should be such directory at least, etc/apt earrings. There is no such file or directory. mkdir -p, and then simply copy this. Now if we run the same command again, then it is successful. Copy it and paste the next command. It also works fine. Now we are going to install the kubelet, kubeadm, and the kubectl. Before that, let's do the update again. Give it some time. And after it is successful, we can simply install the kubelet, kubeadm, and kubectl. So after the installation is done, we will simply mark them as hold. Let me first clear this. So we will simply mark them as hold so that we can ensure that they are not being automatically upgraded whenever we do the next tasks. So all of them are set as hold. We can simply check their version. So all the three versions should be similar. If you look at the version of kubeadm, it is 1.29.6. For Kubernetes, it's 1.29.6 for kubelet, and then for kubectl, it is 1.29.6. So everything is working fine till now. And then we have this CRICTL. So rather than using Docker CLI here. We will be using CRICTL. And after that, we can move on to initializing the control plane. So in this command, we have to be a little bit careful. I'll copy it and I'll paste it here. Node name. The name of node name would be C control plane. And I'll not set the API server advertise address because it will automatically figure it out. And after some time, the command has been finished, and you will find this command here, which has a token. So what we will do is we will simply save it because we'll have to run this on the worker nodes. Why are we running this on the worker node? Because see, in the previous command, what we did was we have defined the control plane component. Now in the worker node also, we need to know which is the control plane component and which is the worker node, right? And we have to connect the worker nodes to the control plane. So that's why we will use kubeadm join so that we can join the worker nodes with the control plane. Simply copy this and paste it uh, in your text editor. Now we will configure the kubeconfig. So simply copy this command and paste it. Then it is the time to install Calico, which will be our CNI plugin. So simply copy it. It gave me some error at the end. Let me do this file again. It says it does not exist. And yes, so now it worked. So now the Tigera operator has been created as well. It has worked fine. And the control plane component is up and ready. If we do kubectl version, it should work. So if we do kubectl get nodes, I hope it works. And we have one component called control plane, and we can see the version and the status is not ready as of now. Now what we will do is we will go to the VM section and let's SSH into the node 01 now. So it took some time and now we are into the node 1. Let me clear everything and let me also go back to this part. So now what we will do is we will go back and we'll have to run the similar commands again. So disable swap, I'll do it really quickly this time. And then the IPv4 forwarding and tables for bridged traffic, enter, set up the sysctl parameters from this, install the container runtime, then set up container D, enable the service, it is up and running, install runc, install the CNI plugin. There is some issue here. Okay. Even in the run C part, there was some issue. It worked fine. Let's do this again. This also worked fine now. I hope I did not miss out anything. Run C has been installed. The CNI plugin has been installed. Run sudo apt update. Then we will run this command. After some time, when this command was completed, we will enter this command. Till then it is completed, I'll copy this, paste it here. It says no such file or directory. And let me create the file here. Mkdir, let's say sudo mkdir -p. It was etc. Let me copy it. And then we can run these two commands. So both the commands were successful. Run sudo update again. And then we will run the installation for the kubelet, kubectl, and kubeadm. Now we will mark them as old, and we can now check their version. All the version are same. Let's go to the command for installing the CRICTL. For that, we'll simply copy this and it is done. Then do not do the step 9 because it was to initialize the kubeadm init. Rather, what we will do is we will go to our text editor, bring this back here, and we will run this. Yes, so we need to run this as the super user. And the node has joined the cluster, you can see. If I go back to my control plane, this is the control plane, right? So if we do kubectl get nodes, let me first clear everything because I cannot see the last lines because of the screen recorder. Now we'll do kubectl get nodes. And what we see is both of them are in ready state, and the node 1 is also the node 1 is visible here basically, which means that the node 1 has been attached or connected to the control plane. So similar to what we did here, this says repeat step 1 to 8 and then join this command. We have already done that. In case you were not able to save this token command here, what you can do is you can simply run this and it will create another token and you can simply paste it in your worker nodes. So now that the node 01 is ready, let's go back and let's go to the node 02. Let's SSH into it. It took some time and now we have done SSH into the node 2. Let's clear it. Let's go back to our tutorial and follow the same steps again. This time I'll do it even faster. Container runtime. Enter this command. The container D is active and running, which is great. Container D was this one. Then install runc. Install the CNI plugin. Sudo apt update. And then run this command. I just copied the wrong command. Copy this, cut it, paste this one here. Again, this will say directory not found. So for that, we'll go back. We'll do mkdir, sudo mkdir -p, and it was etc slash apt slash key rings. Right. Now again, we will run the same thing. It works this time. Sudo get update again. And once it is completed, we will run this command. We will also mark them as hold. Perfectly fine. All of them are working. And then install the CRICTL. Then we will go back to our text editor and we will simply paste this here. And once it is joined, we can check our control plane again. So this is the control plane. We will run the same command again. And it is not present here, the node 2. Why is it so? This is the node 2, right? Okay, so it gives us an error. Okay, so again the same error. We had to add sudo. Now it is done. When I did this command, I did not even look if it is giving me an error or not. I just assumed it would be correct, but that's fine. Let's do it again. And now we can see that we have node 2, which is in not ready status. But if you wait for some time, then it will come to the ready status. Yes, it is ready. So this was the entire process, how we can create a self-managed cluster using virtual machines. Let me do one more thing. Let's say kubectl run nginx image is equals to nginx. The pod has been created. kubectl get pods. I'm doing this just to ensure that everything is working fine. It is in running state. Let me also check all the pods that are present in all the namespaces. So I can see that all these pods are up and running, which works fine. Let me also do kubectl get. Okay, let me first clear this. The daemon sets are also ready and they are working fine. So I think everything is working fine right now. And this is how we could create our own self-managed Kubernetes cluster. I hope this video was helpful to you. If you are looking for more such videos on Kubernetes, Then I do have a lot of videos on Kubernetes on my channel, so you can check them out. In either case, thank you for watching this one, and I'll see you in the next one.